Hello everyone, we are group 3 and this is our project demonstration for computational geometry, project 2. So our project topic is convex hull visualization using Jarvis March algorithm with onion decomposition mesh generation. So these are the team members. Our primary problem statement is given a set of n randomly generated points in 2D Euclidean space. We have to compute the convex hull of that points using the Jarvis March or gift wrapping algorithm. On top of that, we have to also make a simple gradient to visualize the algorithm, each step how it is proceeding. So now let us look at the code working. So we have copied, so we have cloned the repository. Now we will move into the cloned repository. Yes. Now we will run npm I to install all the dependency that will be required in the project. Now we have to run npm run dev. So this is our gradient that we have made. So now let us start with, let's say, 100 points. So these are the 100 randomly generated points in the 2D space. Now let us run the algorithm. As you can see, the algorithm is running and we can visualize each of the step how we are adding each of the convex hull edges. At the each step, what we are doing, we are computing all the angles from the last added edge, and we are find the next edge to be added in the hull. It will have the smallest angle in the counterclockwise direction with respect to the last added edge. So here we can see this edge is the now next edge of the convex hull. Similarly, we'll proceed the algorithm to find the complete convex hull. So here there are 12 vertices and total points that we have sampled is 100. So we know in the Jarvis March algorithm, the complexity depends on the total number of points and total number of hull vertices. So here the complexity will be 100 cross 12. Here are the convex hull point in the anti-clockwise or counterclockwise order that we are expecting from the Jarvis March algorithm. So we are getting it here. Now let us run on one another example. Let's say 140 points. So these are the points. Now let's start the algorithm. So this is the convex hull that we got here for each number of points. So here total vertices are 16 and these are the points in the counterclockwise order. Now, so these are the input output that we expected. This is the Jarvis algorithm where the initialization is done with the leftmost point P naught, which is guaranteed to be on the hull. And then we are running the main loop where we are finding the next probable edge of the convex hull, next edge of the convex hull, and we are adding in the hull. Now, to extend this project on new idea, what we have thought of, let's continue with the example. See here we after creating convex hull for these points, there are remaining points inside the hull which are not on the hull. So what we can do, taking these points as a new points, we can create a new hull, and we can follow recursively and keep creating the hulls until we get the innermost hull with a number of points. Now if left with less number of points than 3, then we can stop. Using this concept, we can create a nested structure of convex hull, and this is already a very standard idea in the computational geometry which already being used very early, and this is called onion decomposition. This onion decomposition have a very general use cases like in robust statistics for outlier detection and for data depth measurement, shape analysis, and it also helps understand the geometric structure and density of the data by peeling successive convex layers. So we have performed the onion decomposition here, and we have used this idea in a creative way for mesh generation. So what we have done, we have created the convex hull, then and this give us the onion layers. Then we remove some edges to create passages and put some fringes and some ghosts on the path to create a beautiful maze-like structure as shown in the image. So continuing with this example, let's generate the maze. So here is the maze that we got from this example. When I will click the show wall, it will show the exact convex hull that have been formed. We have left some of the points, like here 59 points are removed in order to remove the points that are very close to the previous hull. So we will get a clean passage like here. As you can see here in the points, some points are very close to the previous hull. So this will not help us to create a beautiful image structure. So we have left some points that are under some threshold range. So Here we have removed some points and we got this mesh like structure. We can also randomize this and positioning of the ghost and the fruits to get different type of structure from the same convex hull. Then we have put the start and point, and this in this way we have created a beautiful mesh structure which can easily be downloaded from this button and can be shared to the kids or anyone anywhere for printing. We have also smoothened the edges of the convex hull using Bezier curve concept. So this is the smoothened mesh which looks much more beautiful than this walls mesh. And now let us run for some more points like 200. So these are 200 points and this is the mesh generated from these points. And we can always download these images and share with to anyone. So this is the on top extent we have done from the convex hull idea. We performed the onion decomposition, then we performed BGA curve smoothing to smoothen the curve. We applied the thresholds to remove unnecessary points so the mesh structure looks too good, and we have also placed some kids playing elements to make the overall project much more playable and attractive. This is the references that we have used for this project, and thank you everyone.